So logarithms have properties that are sometimes the opposite of what we expect. I do want to talk about where they all come from in addition to showing you how to use them. If I have, for example, something like 2 cubed, and I'm going to multiply that by, say, 2 to the 4th, we can just add those exponents together. That will be the same thing as 2 to the 3 plus 4 power. And 3 plus 4 is just 7. Because, you know, red plus blue is green for some reason. So note that what we have here, multiplication became addition. So we wind up with similar properties when playing around with logarithms, only they're kind of the opposite. Because in the exponential case, this is multiplication outside. That became addition inside. Addition inside. And by inside and outside, I'm talking about that times being outside of the exponent. It's 2 cubed times 2 to the 4th. That addition is inside the exponential. That 3 plus 4 is all an exponent. So we're about to get the same idea, but it's the opposite. Multiplication inside of a logarithm, note that that's m times n all in parentheses, that's going to become addition outside of the two logarithms. So my base is b. We'll go ahead and let that m be blue. So multiplication inside becomes log base b of m plus log base b of n. In other words, multiplication inside becomes addition outside. And these do go both ways. We'll look at examples going both directions. But note that it is the opposite of exponentials, which shouldn't be too crazy because they are inverses. Inputs and outputs flip-flop, so we have an expectation that rules flip-flop as well. It's just a bit weird to kind of visualize this. Actually using it is not too bad. There are two words that you're going to see here, condense and expand. Condense means to put logarithms together. So if you start with 2 or 3 or 4 logarithms, to condense them is sticking them all together. Whereas expand is to break them up. If you start with 1 logarithm, expansion is breaking it up into 2 or 3 logarithms. So let's condense. Number 1 here, log base 2 of 7 plus log base 2 of 4. Well, that is addition on the outside. I'm going to move from addition on the outside to multiplication inside. So that will be the same thing as log base 2 of 7 times 4. Again, it was addition outside. That becomes multiplication inside. Well, 7 times 4, that's just 14. Moving over, log of 25. Remember, there's no number by the logarithm. That's saying log base 10. So our addition here, log base 10 of 25 plus log base 10 of 4, we can bring that together. That is now log of 25 times 4. Because addition outside becomes multiplication inside. 25 times 4 is just 100. Now that's a logarithm that we can actually evaluate. That's one that showed up in a previous example. Log base 10 of 100 is just 2. So sometimes you can go a bit further with these logarithm problems. Again, log base 10 of 100 is 2 because 10 squared is 100. What we want to be comfortable with is doing this with a bit of algebra, a bit of expressions on the inside, because ultimately we're going to use logarithms to solve exponential equations. So addition on the outside, that becomes multiplication on the inside. So we'll have 2x times 4x squared. So to condense these into a single logarithm, we do need to multiply there. So log base 4, 2 times 4 is 8. X times x squared will be x cubed. So again, addition on the outside became multiplication inside. So that's condensing, turning two logarithms into a single logarithm. We also want to be able to expand, turning one logarithm into many logarithms. For 4 here, log base 10 of 6. Remember, if there's no base written, that's a base 10. Well, 6 is the same thing as 2 times 3. So that's multiplication inside. I can turn that into addition outside. Log base 6 is the same thing as log of 2 plus, whoop, that should have been black, and that shouldn't be there either. Thanks, Smartboard. Log base 10 of 2 plus log base 10 of 3. Now that's not the only way you could have expanded this. You'd also do 6 as 6 times 1, log base 10 of 6 plus log base 10 of 1. So there is more than one correct answer for number 4 here. Same with 5. 45 does have several factors, but I'm going to go ahead and use 9 and 5 just to hammer home the idea that multiplication inside can become addition outside. My base is 7, and 45 is the same thing as 9 times 5. So 9 times 5 is 45. Multiplication inside becomes addition on the outside. Number 6 is more aligned with the things that we're going to do when we start solving equations. Note I have log base 2 of 5x. So that's going to wind up being a 5 times x, or multiplication inside. That becomes addition on the outside. Log base 2 of 5 plus log base 2 of x. That's a lot more like something we will actually do when we start solving equations in order to isolate our variables. So this is an example of the product property for logarithms. We will have 2 other properties. They are also going to be properties which are closely aligned to exponents. See you next time.